Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to the first edition of the series of videos on thermodynamics, that is a chapter dealing with the flow of energy that could be in the form of heat or in the form of work from one part of the body to another or from one body to another. So that is why this topic has been aptly named thermodynamics. That means a topic where we shall be talking about the flow of energy. But before we go on to the main topic, there are certain basic terms that we shall be using during the course of this chapter, which we need to understand beforehand in order to be able to relate to what new terms further on we shall be introducing. First of all is system. For example, you have a glass of water in your hand and you want to see how much water you can add to it. If you leave it in a refrigerator, what will happen to it? If you put it on a gas stove, what will happen to it? So in other words, you are studying the water in this glass. See, the water in this glass. Hence, this becomes my center of study, and this is what we call as a system. That means something which we shall study. That means the effect of the surrounding conditions when we study on a certain part of the universe, that becomes our system. That could be a glass of water, that could be a thermos flask, that could be water in a water balloon or air in an air balloon, depending upon whatever you are focusing your attention on. There are three types of system we talk about: open, closed, isolated. I'm taking one example at a time. An open system. This is here. It can lose water. We can add more water. We can add milk. We can add substances to it. At the same time, supposing I put it in a cold condition, it will become cold. It will lose its heat. On the other hand, if I start heating it, the water inside will get heated. In other words, there is a possibility of absorbing as well as losing energy. There is a possibility of absorbing as taking in or as well as losing matter to the surroundings. So there is exchange of energy and exchange of matter in this kind of a system called as an open system. Come to the second example. We have a tightly sealed can. See, turn it upside down, nothing happens. In other words, it is not capable of losing or exchanging matter with the surroundings. I can't add anything to it. I can't remove anything to it unless I cut out the seal of this, unless I cut out the lid of this. And in that case, it no longer would remain a closed system. It will become an open system. A closed system is what this tin is an example of. That means where there is an exchange of energy, but there is no exchange of matter with the surroundings. Here, what is there is, here if this tin is heated or if it is kept in hot water, you will find that the contents of this tin will become warm. So, it can absorb or lose energy to the surroundings, but not matter. Come to the third case, where we will take an example of a completely sealed thermos flask. Now here I'm saying completely sealed, although I'm sure you will say that this is not sealed. No, it is not, because we do not have completely ideal systems existing in nature. So let us assume if this is a thermos flask which is completely sealed and I put hot water in this, that should technically or theoretically remain hot forever, because it is not capable of losing or exchanging energy with the surroundings, nor is it capable of exchanging matter with the surroundings. I can't add more substance to it. I can't remove from it. It can neither lose heat to the surrounding, nor can it absorb. This becomes an isolated system. So to represent it, what we have done is we've drawn a diagram of an open vessel, a tightly closed vessel, a vessel which has got an insulated wall, a completely sealed vessel with an insulated wall. The wall of any of these vessels which is containing the system which we are going to study, the water in this, becomes what we call as the boundary. Now the boundary between what? I'm studying the effect on this water of what? Of everything around it. The temperature conditions, the pressure conditions, the humidity of the surroundings. So those becomes what we call as surroundings. That means anything other than the system which we study becomes what we call as a surrounding. Boundary is nothing but the wall separating the system and the surrounding. How do you define a system? That is what is meant by state of a system. How do we define a person? We say a person has big eyes, black hair, wheatish complexion. So those are the features used to define a system. So same way, state of a system are various physical quantities used to define a system, like pressure, temperature, volume, viscosity, density. All these are examples of the state of a system. So that is why they are also called state variables. These physical quantities being used to define a system. We have two types of state variables, dependent and independent. Your school starts at 7:30 in the morning and gets over at 2 in the afternoon, irrespective of what time the students come into the school. So that's an independent variable. On the other hand, what time you reach the school depends upon what time you have started from home, with what speed you have gone. So dependent and independent variable. Independent means which does not depend on the other. You would have done this in your algebra as well, where let's suppose I have y is equals to 5x. So the value of y depends on the value of x. So my x becomes an independent variable and y becomes a dependent variable. In a typical example of gases, we have PV is equals to RT. That's for an ideal gas equation for 1 mole of the gas. If we specify the pressure and the volume, the temperature automatically becomes defined by the pressure and the volume conditions. Hence, temperature in this case becomes the dependent variable, whereas pressure and volume become the independent variables. State function and path function. State function which will only depend on the state of the system, with what you start and what you end. Simple. Path function which will depend upon the path you take to bring about a change. As we shall study later, you will notice that there are properties like internal energy, independent upon of the path that you take to either increase or lower its internal energy. Whereas path function, for example, work done, will depend upon under what conditions you have carried out that work. We shall be talking more about state and path function once we introduce some more thermodynamic quantities. You will be able to relate to them then. Extensive and intensive property. Intensive, inherent, associated with the nature of a substance. Let us say I talk about density. That's an intensive property. So if I talk about iron, the density of the iron remains the same no matter what part of the block you take it from. So it is an intensive property. The temperature of this will be the same. Extensive property, which depends upon the amount. So if you take a small block of iron, the mass will be smaller. You take a bigger block of iron, the mass will be more. Same way, pressure, volume, all these are extensive properties which will depend upon the mass of the substance that you have taken. Intensive refractive index is an example of an intensive property, a property which is a characteristic property of that material. Thermodynamic processes. What do you mean by process? You go to the school via the school bus, by walking, by cycling, by car. These are all various types of processes by which you can bring about a change in a system. Those processes are categorized into different classes. Isothermal. Iso means same, therm means temperature. A process which takes place under constant temperature is what we call as an isothermal process. In order to maintain its temperature constant, what will it do is it will either gain heat from the surroundings or lose heat to the surroundings. Adiabatic. Adiabatic comes from the Greek word adiabatos. That means something which cannot be penetrated through, which you cannot go through. So here the heat remains constant. That means the heat cannot flow through. For example, if I'm talking about expansion in this thermos flask, this is insulated, so heat cannot flow through it. It cannot flow in, it cannot flow out. Isochoric. Choric comes from the word volume. So a process where the volume remains constant is isochoric. Isobaric. Bar is the unit of pressure and iso means same. That means a process in which the pressure remains constant. Most of all your processes which are taking place in open vessels, wherein you are carrying out the process under atmospheric pressure conditions, are examples of isobaric processes. Cyclic process. Cyclic comes from the word cycle. What happens in a cycle is your wheel starts and then comes back to the same point. That is what is a cycle, right? So cyclic process is where after a series of changes, the system comes back to where it had started from. That means the initial and the final state of the system are same, irrespective of the series of changes that you must have carried out in order to bring those changes. But the initial and the final state remains the same. These are some of the definitions. I would advise you to go through them again in your text. Just read through them, so that will help to reinforce what you would have learned in this particular video. Look out for the second video where we shall be dealing with some more thermodynamic quantities. Don't forget to leave your feedback. Thank you so much.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals, and this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel, there is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.